starting from this section, we will be entering the advanced phase of web development. To make any website look well organized and structured, positioning of the elements is the key factor. Now, when it comes to positioning elements, CSS offers a wide range of rules, and these rules are categorized as CSS page layout techniques. With the help of page layout techniques, you will be able to control every element's positioning which you have defined on your web page. And by positioning, I mean elements spacing, margin, arranging the elements in row and columns, that is creating a grid layout or creating a fixed or responsive web page or designing a fluid layout and much more. As of now, we have seen some common page layout properties like margin, padding or borders, but in this section, we will be looking at advanced CSS concepts like floats, flexbox, grid layout, and the display property, etc. By the end of this section, you will be able to control every aspect of the element's positioning and will develop a better understanding on how the elements get distributed on the web page. CSS box model is actually the way CSS handles every element. And before I further explain box model, let's first observe an example. I'm going to create a main division, that is parent division, with class name container, and I will pass a message here saying box model. Let me create another subdivision with class name content, and inside I'll define two more subdivisions, my heading and topic. Now for the styles, I'll apply simple styling to them like font size, color, margin, padding and text alignment. Now observe this. I'll open the dev tool and I will select the inspect element option. Let me roll over the mouse on this element. You can see that there is some box like area getting highlighted. In fact, when I roll over the mouse on any element, you can see box like area getting highlighted. You can say this as a box which is appearing for every element. What this means is every element inside CSS is treated as a box, and that's why it is CSS box model. In short, CSS treats every element as a box when it comes to applying the CSS rules. Let me select an element. When I scroll down a bit, you can see this layout which is being displayed at the bottom of the styles tab. Now when I roll over the mouse on these sections, you can see that particular section is getting highlighted in the browser as well. As the border does not contain any value right now, it is not getting highlighted, but that does not mean it is not available at this time. It is present but just transparent right now. When I select this element, you can observe here that it is displaying three properties, that is padding, border and margin. So this is what the basic definition of a box model is, that every element is treated as a box that contains properties like content, padding, border and margin. So understanding these boxes is key to being able to create more complex layouts with CSS or to align items with other items. Now let's talk about the parts of box model. First, we have the content. It is the area where your content will be displayed. For example, image, text or any other forms of media content. To modify the content dimensions, properties like height and width are very helpful. Then we have the padding, which sits between the content and a border as white space. It is applied to all sides of the box, that is top, bottom, left and right. Next is the border, which is the area that wraps the content and the padding. Remember that every element has its own border. You just have to switch it on or maybe off, which is by default. Like here, if I give border to the heading, now when I inspect the heading, you can see the border gets displayed. So it's not that I have placed a separate rectangle here to show the box. Every element has its own border. You just have to switch it on to show it. Lastly, the margin. Now margin is defined as the distance between two elements. It wraps the border, padding and the content. Margin does not have any background color and is completely transparent. So this is what a box model is. We will be seeing padding, margin and border in detail as we move ahead. Let's talk about questions. So what is a box model in CSS? So every element in CSS is treated as a box. That's what a box model is. Every box model, every element has content, padding, border and margin. So these are the four properties you use with different values to format the content using CSS. Every element you define inside the web page has its own border, and CSS provides a way to switch the border on for any particular element. By default, the border of any element is going to be in a rectangular shape. For example, let me define few elements here. I will give a heading, creating a division and defining a paragraph inside. Now all these elements which I have defined have their own borders, which cannot be seen right now because I haven't switched it on. So let's try to give a border to this heading. Now the border for any element is defined by specifying the border style, border width and border color. So let me go ahead and give border style. You can give various styles to the border. As you can see, there are various options for styling the border. I will keep the border style as solid. Next is the border width, which defines the thickness of border line. Now this takes length values as well as keyword values like thin, thick and medium, but generally we see that length values are used more often so that they can relate with other properties or designs. I'll keep it 5 pixels. Remember, the more width you give, the more thickness it will add to the border. At this moment, you can see the border is getting displayed. If you won't specify any color to the border, then it's going to take the default color of the element or parent element on which the border is applied, which is in our case white. If I give the color to the element, you can see the border by default takes that color. So to give the border a different color, you will have to give the border color property. And you can see now the border color is different from the element's color. Let me go ahead and define borders for every element we have given. So like I said earlier, that every element has its own border. You can see this division has its own border. This paragraph has its own border as well. Now there is a shorthand property which takes all these values in a single property, and that is the border property. We have already seen this and have used it many times. Normally the syntax goes like this, where we first define the border width, then the border style and then the border color. But the sequence does not matter at all. If you want, you can start with color first, then width and then style, or you can come up with any other combinations. Now there are properties which let you define individual borders with different width, color or style values for each side, like border top, border bottom, border left or border right. You can see this in the snippet. All these properties will let you define different borders for each side of an element. And if you wish to add some border radius to reduce the sharpness of the border edges, you can use the border radius property, which takes length value affecting the edges of the border, as you can see. So this was about the borders and how you can apply them. Padding creates a space between the element's border and its content. Let's understand it with the help of an example. You can see here I have already defined an H1 inside a division. Now I am going to apply padding on this division. So in the style, first I will apply some border on this division so that you can get a better idea how the padding affects the element. Now I will give padding 50 pixels. You can see that when I gave this padding, the H1's content got shifted because now that area has some padding on it. Let me show you. I'll open the dev tool and let me inspect this division. Now in the box model, when I hover on this padding, you can see the exact area the padding is getting applied, which is always between the border and the content of an element. Similarly, let me give padding to this H1 as well. I will give border and padding of 30 pixels to H1. Now when I inspect the H1 and hover on the padding, you can see the padding area of H1. Also, you can see we haven't applied any margin for the element, but by default, it is taking some margin. So let's set the margin to 0 for better understanding. Now you can see the additional space created by the margin is removed. You can set the padding of any element individually for each side or all sides at once. Like right now, both the elements padding, that is this 50 pixels and 30 pixels, is getting applied on all the sides of the element, that is top, right, bottom and left. They are all equal. But if you want to give different padding to each side, you can easily do that. So to give the top padding, I will give the padding top property. Similarly, I will give padding right for right side, padding bottom for bottom side and padding left for left side. So now I have given different padding values to the sides, and when I inspect this division, you can see the area of padding. Now this might look like a lengthy way to define padding to the sides. So to avoid this, there is a shorthand where you can define these values in a single line. Let me give padding. I'll give these 4 values here. So padding takes up to 4 values maximum, and they are in the clockwise order, also known as TRBL, that is top, right, bottom and left order. The first value defines the top padding, the second is right, the third value defines the bottom padding, and last value defines the left padding. So this is the order which you have to keep in mind when giving multiple values to the padding, that which value is going to affect which side. If I give 3 values, let me change this to 30 pixels. Now when there are 3 values, then the first value will define top padding, the second value will define right and left paddings, and the third value will define the bottom padding. If I give 2 values, then the first value will define the top and bottom padding, and the second value will define right and left padding. Now things get pretty interesting when you give percentage value to the padding, because when you give percentage value, then that padding is defined based on the parent element's width. Suppose I give 10% padding to the H1. Now when I inspect this H1, you can see the padding is approx 22.4 pixels. How? Because the pixel value for 10% is 0.1 pixels, right? Now this is how the padding gets calculated with percentage units. Let's check the width on the parent element, that is this division. So if I inspect this division, you can see it has a width of around 224 pixels. So the padding gets multiplied with the width of the parent element, that is 10% into 224 pixels, which equals 22.4 pixels. Let's check it one more time. This time I will define width to the division. I will give 350 pixels width. Now when I inspect the H1, you can see the padding has changed because the parent element's width is different. So the padding of H1 is getting multiplied with the parent element's width. That is 10% into 350 pixels, which equals 35 pixels. This is how the padding gets calculated. When given in percentage, it will always relate to the width of its parent element. Let's talk about questions. So why do we need padding in CSS? Well, when you want to create a space between the element's border and its content, that is where you define the padding property. The second question is, what is the order of values with respect to the element's side in padding shorthand property? So the order of values is top, right, bottom and left, that is TRBL, which goes in the clockwise direction. The third question is, what happens when you give padding in percentage? So when you define padding in percentage, then that element's padding will relate to its parent element's width. That is, the padding will be multiplied with the width of the parent element. Just like padding, margins are used to create space around the elements but outside the element's border. As margin is the outermost portion of the box model, it creates a space outside the element's border. Let's take a practical example where I have created a paragraph inside the division. Now for the styles, I will start by giving a border to the division. And for the paragraph, I am giving a border and padding. Now watch the output. When I give margin 50 pixels, you can see it added the space around all the sides of the element, outside the element's border. Just like padding, it takes up to 4 values representing each side of an element in a clockwise order, that is, top, right, bottom and left. Right now the margin is 50 pixels for all the sides, as you can see in the box model. If you want to give individual margin to all the sides, you can make use of these properties: margin top, margin right, margin bottom and margin left respectively. To set all these property values in a single property, you can use the margin shorthand property. Like here I've given 50 pixels, that is single value, which makes all the 4 sides of the margin equal. So if I want to give different margin values to all the sides, I will have to give 4 values here. First value for top margin, second for right margin, third for bottom and fourth goes for left margin. Similarly, if I give 3 values, then the top margin will be 50, right and left will be 100 and bottom will be 60 pixels. And when I give 2 values, then it is top bottom margin, that is 50 pixels, and right and left, that is 100 pixels. Now each of the margin properties accepts a keyword value, auto. This keyword tells the browser the margin for you. In most cases, a value of auto will be equivalent to a value of 0, which is the initial value for each margin property, or else whatever space is available on that side of the element, auto will consider that value. Auto is very handy when it comes to horizontally centering the element within its container. So if I give width to the parent container and specify the margin to auto, you can see the element is now center aligned. Considering the width specified, the remaining space will be filled up equally by the left and right margins. Without the specified width, the auto value would essentially have no effect. Also, the auto value is useful only for horizontal centering, so using auto for top and bottom margins will not center an element vertically. Let's talk about questions. So, how does margin differ from padding? A margin creates a space around an element's border, while padding creates a space between an element's border and the content. In other words, the margin property controls the space outside an element, and the padding property controls the space inside an element. You can also say that padding is the closest property to the element's content, while the margin is the farthest from the content. Second question, how can you center the element using auto? When you have specified the width of an element, setting the margin as 0 and auto will make the element sit centrally within the parent container. Specifying auto as the second parameter basically tells the browser to automatically determine the left and right margins itself, which it does by setting them equally. It guarantees that the left and right margins will be set to the same size. The first parameter 0 indicates that the top and bottom margins will both be set to 0. But remember that this only works on the block level elements, and the auto will center the elements horizontally and not vertically. It does not set them vertically centered because the W3 specs for CSS are designed in such a way. Margin collapsing happens when the vertical margin, that is top and bottom margin of two block level elements, sometimes gets combined, that is collapsed into a single margin. To illustrate this, let's check an example. I will define two elements, say heading and a paragraph. Now let me apply border to them. So I will give a border to H1 and a border to paragraph. Now let's apply some vertical margin between them. For H1, I will give the bottom margin of 60 pixels, and for the paragraph, I will give top margin of 20 pixels. Now when I inspect this paragraph, you can see the top margin area getting highlighted, and when I inspect the H1, you can see the bottom margin area, which is till the paragraph element, that is the margin touches the paragraph element. What really should have happened is that the vertical margin between these elements should be a total of 80 pixels, that is 60 plus 20. But eventually the margin collapsed, and now the actual margin remains 60 pixels only. This behavior is known as margin collapsing. To avoid this, there are ways like using flexbox or grid layout or even padding in some cases. But first, you need to keep in mind that margin is meant to increase the distance between siblings and not to increase the gap between a child and its parent's bounding box. That's what padding is for. The more you will work with margins, the more you will understand its functionalities, and you will be able to point out where the margins are getting collapsed. There is one more concept, and that is negative margins. If I give here minus 20 pixels, then you can see the paragraph is pulled towards the heading, that is margin has decreased. Negative margins allow us to reduce the space between two elements. It lets us pull a child outside its parent's bounding box or reduce the space between siblings until they overlap. The collapse of negative margins is same as the positive ones. Whichever margin is dominant, that is greater, will show the significance. If I change the bottom margin of heading to 20 pixels, then the margin will have no effect, as the positive margin and negative margin cancel each other out. Negative margins are used when you want to remove unwanted margins, like by applying negative margin to a parent element, you can cancel out unwanted margin. You can also give multiple negative values to remove or adjust the space between the elements. So these were the few important concepts related to margins. Now let's talk about relative questions. The question is, does the margin collapse horizontally? Well, absolutely no. Margins never collapse horizontally because it simply does not satisfy the conditions which make a margin collapse horizontally. Only vertical margin can get collapsed. The second question is, what causes margin collapsing? Collapsing of margins happen when two vertical margins come in contact with one another. If one margin is greater than the other, then that margin overrides the other, leaving out one single margin value which is the greater one. The float property is very important when it comes to giving flexibility to your web page. Think of a float property like this. When you define the elements on the web page, they all have some sort of fixed position, like they are rigid. But by giving float property to them, you are allowing them to float freely anywhere on the web page. Let's look at an example. I'm going to create 3 divisions and name them as element 1, element 2 and element 3. Now I'm going to apply few styles to the division. It's going to be common for all the divs. I'll give width, height, margin, font size, border, the radius, text align and line height. Right now we have got a normal document flow. That is, you can see these elements are in their normal state. They are stacked in an orderly format. Now with the float property, you can give one of 5 values supported by all the browsers. That is right, left, none, initial and inherit. Let's see what happens when I give float right to element 1. You can see the element 1 is now at the extreme right side of the document and the divisions 2 and 3 are shifted upwards. So when you apply float on any element, that element is taken out of the normal flow of the document and the below element will take that space because now the space where element 1 was at is empty, as the element 1 is removed from the normal flow of document. So the non-floated element will consider the empty space and fill that up. Now observe what happens when I float this element to left. You can see it is overlapping the element 2 as the element 2 and 3 are still in the normal document flow. They are still filling up the empty space of element 1, as we have removed the element 1 from that flow. So you are allowed to overlap other elements using the float property. Similarly, if I float element 2 to left, then element 3 comes underneath element 1 and element 2 comes aside the element 1 as it got removed from the normal document flow. If I float the element 3 to left as well, you can see a queue-like structure. This technique is very useful when you want to make a photo gallery like structure or horizontal menus. Now let me float all the elements to right. I will give float right to the division element and remove all the previously defined floats. So all the elements are floated to right. You can see how it affects them. Now if I float the element 2 to left, you can see element 3 fills up the empty space as element 2 is floated left. Now let me change the value to initial. The initial will bring the element back to its initial position, but as element 1 is floated right, element 2 will fill up that beginning space. If I also give initial to element 1, then you can start seeing the default structure which we were at the beginning. The float inherit will simply inherit the float property from its parent element, and the float none will clear out the float applied on the element. Let me give none here to element 3, and you can see it clears the float on it and brings it back to its default place. The only difference between the initial and none is that initial is still a floating value which tells the element to float at its initial position, while the none will clear out any floating applied on the element. Float is also very useful when you want to wrap the text around the element. Like here, let me give paragraphs after each division. Now what I want is, I want to move these paragraphs next to their divisions. First, let me give padding to the paragraph. So I will apply the float like this. For element 1, I will float it to left, for 2, right, and for 3, left again. And you can see how the text wraps around the divisions. So understanding and mastering floats is very important, because apart from just wrapping text around the elements, floats can be used to create an entire web page layout. We will see various situations with floats as we move further. While floating is used for creating a web layout, the clear property, on the other hand, is used to clear out the floats from the element to restore the normal document flow. Together, the floating and clearing allows us to have precise control over the flow of layout. Clear property can have one of 5 values supported by all the browsers, and those are right, left, both, none, and inherit. So let's check out these values. I am going to continue with the example which we saw in the previous lecture. I am going to make few modifications to it. First, let me remove all the paragraphs from the HTML file. Next, I will remove the border radius and all the float properties, and also let me remove the paragraph class. Alright, so you can see we have 3 rectangles stacked on one another. Now I will set element 1 to float left and element 2 to float right. And as usual, we have overlapping problem as we have seen in the previous chapter. I am going to give the different heights to the first 2 elements, that is element 1 and 2. I will set 200 pixels to element 1 and 300 to element 2. And also let me set the width of element 3 to 95%. Now it's clearly visible that element 1 and 2 are floating and they are overlapping element 3. So let's solve this by using the clear property. In element 3, I will give clear left. This means it will not allow the elements to overlap that are floating left, but elements that are floating right are allowed to overlap it. Now if I change it to clear right, this means it will not allow the elements to overlap that are floating right, but elements floating left are allowed to overlap it. Let me set the height of the element 1 to 400 pixels, and you can see element 1 is overlapping element 3 again. Now if I change it to clear both, it will not allow any floating element to overlap on it, as you can see. Element 3 will be shifted at the bottom side of the element which is having the maximum height by not allowing any floating element on it. Let me reset the element 1 height to 200 pixels again to confirm. Now clear none will reset the element position back to normal as per the document flow, whereas clear inherit will just inherit the parent property of clearing the flow. Remember that giving float and clear property together inside an element is not a desirable approach. You can give them together, there is nothing wrong with that, but when you float an element and clear a direction, you are simply adding a page break to the document flow. if the cleared element is followed by another floated element in the same direction, it's going to float in the given direction like here. Let me remove all the height and width settings of the elements and set the floating to right. Now when I clear the right side of element 2, you can see that element 2 and 3 are brought down. So this was all about the clearing of floats. It gives you a precise amount of control over which elements you wish to float and which elements you wish to bring back to normal document flow. Let's talk about relative questions. So the question is, how can you control the behavior of floated elements? If you don't give the clear property, then the elements will overlap or clutter up with the existing floating elements. When an element is floated, it is taken out of the normal document flow. Now this creates a situation where the containing block, that is the parent element's height, may get collapsed, making it look like as if the child elements are no longer inside the parent container. This behavior can cause many unwanted situations, like the background of the parent container gets disappeared or contents within gets overlapped, etc. So let's create an example for the same and we'll see a few ways to avoid the collapse. I'm going to create a parent division which will contain 3 child divisions. Now I'm going to apply some styling to the parent division like padding, width and border. And we'll also style the child divisions, but before giving individual properties, let me add padding and margin to the child divisions. I will use the child selector for that. I'll give background color to each child division. Now observe what happens to the parent container when I float every child division. You can see the parent container getting collapsed. That is, the height of the parent container gets 0. If you want to check, let me open the Dev tool, inspect the parent division and go to Computed tab. You can see the height is 0 pixels because the height of the parent division is based on the number of elements which are inside, as we haven't given any height to the parent division explicitly. There are many ways to avoid this kind of collapsing, and being a front-end developer, you will face many different situations like this. So the first way is simply float the parent element in whichever direction you want, but mostly in the same direction as the child elements are floated. If I give float left, then you can see the container is back again the way we wanted. Another way is to give height to the parent container. Or you can define a blank paragraph and apply clear property to it. Why only empty paragraph? You can also give text inside. It will solve the problem as well. Let me undo the paragraph HTML and CSS both. If you do not want to add any extra elements, then there is another approach in which you will have to give the property called overflow inside the parent container. What overflow does is it defines what you want to do with the content which is too big to fit in that area. It takes one of 4 values, that is visible, auto, hidden and scroll. We will see this property in a more detailed lecture, but right now let me just give hidden. Hidden is going to clip off any content that overflows from the area, and you can see it stopped the container collapsing. So these were the few ways you can use to deal with collapsing of the container. Now, collapsing is an important factor to be considered, which you want to prevent, otherwise it leads to strange layout and cross-browser problems. Let's talk about relative questions. So, explain what is container collapsing, or why the container gets collapsed when elements are floated. So when all the elements inside the parent container are floated, the height of parent container gets collapsed, that is, it gets to 0 pixel. This happens because all the floated elements are taken out of the normal document flow, so the parent element does not recognize the sizes of the floated elements and acts as if nothing is contained in it. As a result, it is set to 0 pixels. So this is what container collapsing is. In the previous lecture, we saw different methods for handling container collapsing. Now all these methods may get the job done, but developers still face issues regarding the page layout after performing these methods. So they came up with a newer way which prevents collapsing of containers and also don't mess up the page layout too, which they named as clearfix method. So let's see how it works. I'm going to define a division with class name clearfix, which will contain 2 images. I will define image tag giving the source and width, making a copy of this image tag, and lastly we'll give a paragraph. Now I'm going to float all the elements so that the parent container gets collapsed. First I will give border to the division. Now I will float the elements. You can see the container has collapsed. Now the clearfix approach makes use of the after pseudo element because it adds a content after the element. So this way you can clear that content and avoid the collapsing without adding different block elements to the document and then clearing them. So I will go ahead and give the after pseudo element to the div and I will keep the content empty. Next, we make sure the visibility of this stays hidden. So I will give visibility property and set it to hidden. Then I will give the clear property. I'll say clear both. Still the container remains collapsed as the height of the content is still not there. So to sort this out, the display property works as a real charm. I will give display block. Now when I say display block, it's going to tell the browser to display the element on a block level. And you can see the container gets cleared and there is no more collapsing. So following this approach, we'll apply a small bit of content which remains hidden from the view as the parent container clears the floats. To sum it up, clearfix is a way which tells the element to automatically clear its child elements so that there is no need for you to add the additional markup inside the document in order to clear the parent container. Now, there are still some browsers which do not support this approach. That is, giving the empty content. To be specific, browsers less than the IE8 versions, you will have to go with the older approaches which we saw in previous lectures, like floating the container element in the same direction as child or defining height in the collapsed container or adding additional markup inside the HTML, then applying clear property to it or giving overflow property inside the collapsed parent container, etc. There are still various ways to perform clearfix, but that depends on what kind of situation you are dealing with, but this approach is quite popular and easy to use. Now that you have understood what floating is, I'll be showing you a few common approaches on creating float-based layouts. The most popular layout approach which various websites follow is the column layout approach. You may have seen or come across such websites. So let's try to implement a column layout with floats. I'm going to start by defining a header. I'll say my profile. Next, I'll define an article tag and I'll give 3 divisions inside, naming them as first column, second column, and third column. Lastly, I'm giving a footer. Alright, let's style them. I'll define width first, inside the body as I want to fit the content in this area. Let's style the H1. I will give the background color, aligning the text to center, giving some line height, text transform to uppercase, letter spacing and bottom margin of 25 pixels. Next, we will style the first column division. I am giving the background border height 100 pixels and width 120 pixels. We'll give some padding also, I'll say 1.5 rem, and we'll give some right margin. And you can see our first column is completed. Now I'm going to copy these properties and will rename the class to second column. Similarly, for the third column, I'll paste the same properties. We won't need the right margin for third column, so let me remove it, and instead let me add bottom margin of 25 pixels to create gap between the div and the footer. Now for the footer, I will give background and padding. You can see our basic structure is ready. Now to display them in column format, we have to apply floats to them. So let me give float left to all the columns. And you can see a 3-column layout is displayed. You can also notice that the footer is stretched all the way as the columns are floated, and right after the third column, you can see there is some space. This tends to happen when you float all the elements in a similar direction. So let's fix this. For footer, there is an easy fix, which is simply applying clear property. I will give clear both, and you can see the footer is back to its place. Now to fix the space in the third column, I will change the float direction to right instead of left, and you can see the space has been filled. Also, I will remove the margin from the second column as we don't need that anymore, because the width is going to provide the spacing between these two columns as they are floated in the opposite directions. So you can see there is no extra spacing to left or right. And you can also notice that the gap between the second column and the third is a bit off. You can fix that by slightly changing the width. Let me change the width of all columns to 136 pixels. We are now ready with our 3-column layout. So this is the technique which you can use for creating a 3-column layout. So by mastering the floating and clearing techniques, you can create the basic structure of any layout you wish to create. Just make sure that your layout allows flexibility and presentation the way you want. The display property allows you to specify the display behavior of an element. It is one of the most commonly used features in CSS development. As you know that HTML renders all the elements in a box, so the display property is used when you want to determine how that rectangular box should be treated, that is, as an inline element or block element. The default display value of most of the elements is either block or inline. So let's understand the display property with an example. I'm going to create 3 divisions inside the body, having the class names as first division, second division and third division. Now let me give same width and height and different background color to all the divisions. Right now the default value of display is block for all these divisions, and to check that, let me open the DevTools. I'll inspect any division and click on the computed, where you can see the display property as block. The block elements will always take the full width of space in the browser by default if not given specified width to the element, and will always start from the new line. Now let me set the display as inline for all the divisions, and you can see that all the divisions are in a single line now. So this is how the inline elements are displayed, that is side by side in a single line. You can also notice that the width and height is no longer affecting them because it is their tendency to ignore the width and height, as the width and height of inline elements are determined by the content they hold. Even if you give display inline to any block element, the height and width of that element will be ignored. Now there will be cases where both the display values, that is inline and block, won't be enough for a better web design. This is where the inline block comes to the rescue. As the name says, it shows the characteristics of both these properties. So let me give here inline block and remove inline from all three classes. And I'll also tweak this width and height in order to generate the desired result which I want to show you. Right, this is how the inline block works. You can see the elements are arranged inline but also on a block level. You can also notice that now the width and height is working fine. So when you give inline block, you won't face issues regarding width or height not getting applied. But when displaying elements inline, their height and width will be ignored. Display property also allows you to remove an element from the view. So let me give display none to the second division. And you can see it removes the second division from the view. Not only it gets removed from the view, but also the display none removes the element completely from the DOM as well. This is why division 2 acts as an empty space, and thus division 3 takes up that space. If you compare this with visibility hidden, let me set visibility hidden in first division. You can see it hides the element, that is, it makes them invisible rather than removing it from the document. This means that the element is still there, and that's why division 3 is not taking that empty space. So these were some of the values which are widely used with the display property. Apart from these values, display property offers various other values like flex, flexbox, contents, grid, inline grid, list item, table, etc. We will check them in our upcoming lectures. Let's talk about relative questions. So the first question is, explain the purpose of using the display property. Well, it is used for specifying the display behavior of an element, that is, whether you want to display that element as a block or inline on a web page. Second question, differentiate between display none and visibility hidden. So display none will remove the element from the layout flow of the page, allowing other elements to take up that empty space, while the visibility hidden is going to make the element invisible, that is, it will hide the element but the space still remains intact. The third question is, why are width and height ignored on a displayed inline element? When you specify display inline to any element, or even if the element is an inline element by nature, giving them width and height won't affect them, because the width and height of any inline element is determined by the content they hold inside. When designing a website, you may think about what kind of layout approach you want to go with. That is, either you want a fixed or static layout, or you may go with fluid layout or responsive layout. Now, the decision of selecting a layout totally depends on the usability of the website, because each of the layout has its own advantages and disadvantages. Either one can be used to make a successful website layout as long as you keep usability in mind. So let's start with the fixed layout. Fixed layouts are static layouts whose width is kept fixed by giving pixel unit to the container. The container of a website is kept in such a way that it does not move, that is, it remains fixed at a position. That's why it is called fixed layout. No matter what screen resolution the device has, the width or size of the container will remain steady and will not adjust as per the device. Generally, for fixed layouts, there is a standard width size set for the container, and that is 960 pixels. Now, this width size is most widely used when setting up the container's width for a fixed layout website. But viewing such layouts on a smaller screen gets really messy, as in many situations a horizontal scroll pops up which ruins the flow of the website and overall experience of users. In fluid layout, which is also referred to as liquid layout, majority of components in a website contain percentage length values so that the layout can adjust with the screen resolution. Now, this means that whenever the screen size is changed, the elements will adjust accordingly in a proportionate manner. With the fluid layout approach, you can create more user-friendly and flexible websites, and also, if designed well, you can eliminate the horizontal scroll which appears when the screen resolution gets smaller. Another alternative, and the best one, is creating a responsive layout or responsive web design, also known as RWD. Responsive web designing is a modern approach for web designing, where the content renders smoothly and adjusts itself with various screen sizes, whether it can be computer, tablet, mobile, or a TV. It includes a combination of length units like percentages, viewport width and height, and several rules like media queries, so that the layout design can automatically adapt with the browser to maintain consistency across various platforms. Responsive web designs totally focus on handling screen sizes up to greater extent, as the contents are placed relative to the viewport's length. So these are some widely used designing approaches. Remember, all these layout approaches have their own pros and cons, but at the end, what's important is the designing of the layout, which should be done with some precautions, and that takes time and effort. Now, I'll talk about relative questions. So explain the difference between fixed, fluid, and responsive layout. Fixed layouts are static layouts in which the layout remains fixed upon resizing the screen, that is, it won't adjust with the screen resolution. Majority of elements are assigned with the pixel unit, be it their width, height, or margin. Whereas in fluid layout, whenever the screen is resized, the elements or the content adjusts itself accordingly, proportional to the screen. It makes use of percentage length unit rather than fixed pixels. And responsive layouts are much better than the fluid and fixed layouts, as the content renders smoothly and adjusts automatically whenever the screen size is resized or the resolution gets changed. It makes use of media queries and viewport units so that the layout is related with the overall viewport. In web designing, grids can be very useful when you want to deal with the phase of how and where to place elements on the page. It guides you for delivering consistent page content. Now, these guidelines incorporate margins, spaces, and columns collectively. Let's first understand the grid anatomy by creating an example first. I'm creating a container section, and inside, let me define 8 subdivisions. Now let's style them with background color, text aligned to center, border, padding 15 pixels, and font size. Right now they are displayed as a block. To make them display as a grid, CSS offers the value grid for the display property. So inside the container, I will give display grid. Now, when a container element is applied with display grid property, that element becomes a grid container. As in most cases, it acts as a direct parent of all the grid items, that is the child elements. By giving only display grid does not make the elements display in a grid, because grid layout consists of rows and columns. So after displaying them as grid, we need to define the row and column sizes. This is what gives a grid layout upper hand when compared with other layouts, as you won't need the floats and positioning properties with grid layouts. So let's apply columns and rows. For giving column and row length to a grid, CSS offers these properties: grid template columns and grid template rows. The grid template columns specifies how many columns with particular width you want in a grid. So if I give 4 values, it will create 4 columns grid layout. If I give 2 values, it will certainly create 2 columns grid layout. And if I give 5 values, it's going to create 5 column grid layout. As you can see, and the values are separated by space here. I will keep it to 4 values as it distributes the items equally. For giving the row length, as we have 2 rows, I will give 2 values. There can be some situations where there are many rows and columns. In that case, you cannot give individual values to both of them. So to avoid that, there is a function which is especially used with rows and columns, and that is the repeat function. So instead of giving individual values, you can give 2 values inside the repeat function. The first value takes the total number of rows or columns, and the second takes the height value for row and width value for column. And you can see this gives us a simple grid layout. Let me add 2 more properties. I will give margin and justify content to center. Now, talking about the flexibility, right now the grid is not flexible. As you can see, when I resize the output window, the grid stays the same. To make a grid flexible, you sure can use percentage values. Now when I resize the output window, you can see the grid becomes flexible. That is, it's getting adjusted with the window size. But a problem with percentage values is that they do not count or calculate the free space available within the grid container. To clarify that, let me give a border to the grid container, and you can see the grid is outside the container right now, and we don't want that. To avoid this, there is a unit which is specially made for the grids, and that is the fraction unit. The fraction unit works only with the free space available inside the container. It is also responsive and flexible. So let me give here fraction instead of percentage. I'll change the value to 2 fraction for columns width and 1 fraction for the row height. And you can notice as soon as the fraction unit is applied, the grid gets wrapped inside the container, and now when I resize the output window, you can see it does not overflow. You can also combine this fraction unit with other unit as well. Like for a moment, let me remove the row property and border, and also I'll alter the column values. I'll say 1 fraction, 1, 1 and 200 pixels for the 4th column. Now when I resize the output window, you can see the first 3 columns are responsive and the 4th column stays fixed. Let's try another combination with percentage value. I'll say 40%, 1, 1 and 2 fraction. So the browser assigns 40% of the viewport width to the first column, and then it divides the rest of the space into 1 by 2 fractions. These are kind of grid layout approaches you can perform. There is another useful property which you can apply to grids, and that is the grid gap property. This property gives space between each grid item. This space is often referred to as gutters in grid anatomy. Gutters are the lines between the columns and rows which separate each of the item. So let's apply grid gap property. I'll give 10 pixels and you see how each item gets separated. You can also give space between columns and rows individually by giving column gap and row gap properties. So instead of grid gap, I'll give column gap 10 pixels. You can see only the columns get separated, and row gap 10 pixels. This separates the rows. So this was some basic grid approach and anatomy which you need to understand and practice thoroughly. In the very next section, I'm going to show you some advanced and complex grid approaches where we will learn the spanning of rows and columns in grid layout. Now let's talk about questions. So how will you generate a grid layout with CSS? Well, you have to give the display grid property to the containing element, and then you define the rows and columns of the grid as we saw earlier. The second question is, explain the fraction unit. The fraction unit has been created just for the grid systems, as it works only with the free space available inside the container, making the grids responsive and flexible. The next question, how will you create a grid of specific rows and columns? By using a grid template rows or columns properties, you can define the number of columns and rows you want. Each value in the grid template columns also defines the width of the grid column, and in grid template rows, each value defines the height of the row. Next question is, what is a grid gap? Well, the grid gap is also known as gutters in a grid system is denoted as a space between the rows and columns, and to manipulate it, CSS provides the grid gap property, which is the shorthand for row gap and column gap properties. In the previous lecture, we saw how to get started with grids by understanding some grid anatomy and basic layout structure. In this lecture, I'll take grids one step further, as we will see how to create complex grid structures by spanning the columns and rows. Now by default, the content in a grid is placed in individual grid cells, but you can set any grid child to span multiple columns or rows or even both. I am going to continue with the same code which we saw in the previous lecture. So let's get started. You can see the output of this code. Let me set all the columns to one fraction first to understand the example in a better way. Now if I want to span the first content up to the column ending, this is how I will do it. Inside the item, I will specify the grid column start to 1 and column end to 5. And you can see it spans the 4 columns. These properties make use of grid column lines for calculating the column start and end. And the grid lines look something like this. So you can make out how the column spans. If I change the starting value to 2, then the A will start from the second column line and it will span up to the 5th column line. If calculating column line looks complicated, then there is a span keyword which directly tells how many columns to span. Let me add the span keyword before the value 5. Now you can see it spans 5 columns instead of 3. Remember, adding span keyword will not consider calculating the grid column lines. As you can see, the output is different from before. It's going to span the exact number of columns which is specified. If I again change the end to span 3, it will span 3 columns. Similarly for the row, let's span the row of B. I will give the start point to 1 to start from the first row, and I will give the end point to 4 for spanning. Looking at the grid lines, you can easily understand how the grid rows are calculated. Now, there is a shorthand for specifying the start and end points of the grid columns and rows. By giving the shorthand grid column and grid row, which takes two values, starting point and ending point, you can achieve the similar result. So let me comment these two lines and I will give the grid column property, keeping the start point to 2 slash and end point to 5. This is how the shorthand syntax looks. You separate these two values with a slash. You can also add the span keyword here for spanning the specific number of columns. I want to span 3 columns. I will write span 3 instead of number 5. Similarly, for the row, I will comment the first 2 lines and will give the shorthand, that is the grid row. Or you can span the number of rows by adding the span keyword. So spanning of elements is very useful with grids, as you can create a perfect web layout in a consistent manner. Let me show another example for creating a simple layout with grids. Let me give grid gap instead of row and column gap. Let me remove the comment lines from div A and change the grid columns to span for 5 columns starting from 1. For division B, I will again remove the comment lines and change the grid row starting from the second grid row and span for 2 rows. Also, let me give a height of 150 pixels. For division C, I will give grid column where I just want to span it for 3 columns. Here you can see we haven't given the value from where it has to start the spanning. So by default, it will start from its current position. Right now, the div C is located at the second grid column line, so the start position will be 2. You can see there will be no change if I write the starting position to 2 or just leave it. For division D, I will give span 2 rows. For division H, I will span 5 columns. And for child E, F and G, I will just leave it as it is. So our layout is ready. Now if I just assign them proper names, giving header, main content, sidebar, menu, sub-content and footer. Now this looks perfect. So this is how you can use grids to customize your own layouts, and there are many approaches to achieve or create any complex grid layouts. So now there is an assignment. You just have to create the following nested grid layout. You just try it out and come back again to check the solution also. I hope you have tried it. Let's see it together. I'm going to do some changes in the HTML code which we just saw. Moving this division E, F, G inside the division C and remove the text from division C. Let me insert a space before the child divisions so that it looks in the proper flow. Alright, so this is the first step. When you are going for a nested grid layout, that is, you nest the elements inside another element, now this division C acts as a container for all these subdivision elements. So inside the styling of division C, I will display this container as a grid. Then I will add 3 columns of 1 fraction. Next, I will give the grid row and will span 2 rows. And we have the desired layout. So this is how you create the nested grid layout. Flexbox, which is also referred to as flexible box, is a layout model which helps you design and create advanced web layouts, which are difficult to achieve using other layout models. Flexbox provides flexibility and overall control on how the elements are positioned, sized, or aligned within their container, as you can flex the items to different sizes to fill the space or make them aligned vertically or horizontally, or maybe change their order of appearance or their direction, etc., making the design responsive and easy to work with. Flexbox is supported by all the modern day browsers, so it won't be having any compatibility issues. Flexbox offers a wide range of properties for customizing the container element as well as the items which are within that container. Some of the major benefits working with Flexbox is that it makes the making of navigation bars or menus very easy, in a way that you won't be needing any floats, so you don't have to worry about the elements getting collapsed. Creating grid layouts with Flexbox is an easier approach and very simple to work with, like creating equal height columns and much more. Now, before we move on to the properties used with Flexbox, it's essential to understand the terminology of Flexbox first. Observe this diagram. There is a Flex container which contains 3 Flex items. The Flexbox is used for creating one-dimensional layouts. So every Flex container contains a main axis, which is a primary axis along which the Flex items are displayed. The direction of the main axis is based on the Flex direction property, which we will see shortly. Then it has the main start and main end, which describes the main start side of the Flex item and going towards the main end side. Next is the main size, which is the width or height of the Flex container or Flex item, whichever is in the main dimension. Then comes the cross axis, which is always perpendicular to the main axis and its direction depends on the main axis direction. Cross start and cross end specifies the placement of items inside the Flex container, starting from the cross start side of the Flex container and going towards the cross end side. And lastly, the cross size, which is the width or height of a Flex item, whichever is in the cross dimension, becomes the item's cross size. So this was some basic information, some terminologies about the Flexbox which needed to be shared before we start working with them. Let's talk about a relative question. So what is a Flexbox? So it's a flexible box that is a web layout approach which makes customizing of complex web designs easy. It provides flexibility and overall control over the element's positioning, alignment, or size, etc. Flexbox can be created by giving display::flex inside the container element, though it's not just that which is going to implement the complete flexible box layout. When it comes to Flexbox properties, there are many different properties which Flexbox offers, and they are separated as Flex container and Flex items properties. I'm going to divide this Flexbox session into 2 lectures. One which we are going to see in this lecture will be about the properties applied on the Flex container, and the next second lecture will be about the properties applied on the Flex items. So let's start with an example. I will create a section with the class name as wrapper, and inside I am defining 4 items. Now let's style the items. For item A, giving the background, padding 2 rem and margin 10 pixels. Similarly, for the rest of the items, I will apply the same styling apart from the color. Now, as you know, by default, these items are displayed as block. To display the items as Flexbox, you'll have to give the value flex. So I will give the display::flex property to the section. As you can see, all the items are displayed in flex, which is in a row-wise manner. Now there are certain properties which can be used inside the flex container. Let's give the justify content property. This property is used to align the container items when the items do not use all the available space on the main axis. So let me give justify content to center. You can see it centers the items. If I give flex end, it will shift all the items to the flex ending. If I give flex start, it brings back the items to the starting point of the flex container. Next useful values are space around, space evenly, and space between. If I give space around, you can see it adds the space before and after every single item. If I give space between, it's going to add space only between the items. And if I give space evenly, it will add space evenly around the elements. Next property I will apply is the align items. Now this property aligns the items on the vertical axis of the flex container. The first and default value is stretch. This value will stretch the items to fill the container. Right now you don't see the result because by default this value is applied to all the flex items. Let me give a border to the wrapper. Now if I increase the height of the wrapper, the inside items will also stretch according to the wrapper height. If I comment the align items property, still you can see it is working as this is the default behavior applied on the flex items. Let me undo the comment. Now let's try different values with align items. First, I will give different heights to the items in order to understand the align items property. As we have given different values to all the elements, the stretch property will not work and the default value of align items changes to flex start. Let me give flex start and you can see nothing has changed. And I'll apply flex end to the align items. You can see what it does. It aligns the flex items to the end or bottom of the container. If I change it to center, then all the items will get centered vertically. The next value is the baseline. Now what baseline does is it aligns the flex items along their contents baseline. In many situations, you won't be able to distinguish between baseline and flex start. As you can see, it shows me the same result, which we saw when I applied flex start. So how to make a baseline value noticeable? Simple. You can give some font sizes to the content. So if I give font size to the item A and item C, you can then notice how the items are getting aligned on the basis of their baseline. Important point with baseline is the alignment of the item will be determined by the tallest item in the row. Now if you change the value to flex start, you can understand the difference between baseline and flex start. So this is what align items used for. Next property we will look at is flex direction, which accepts one of four values, that is column, column reverse, row and row reverse. This property is used to display the flex items in a particular order within the container. The default direction value is row. Let me remove font size and heights from all the item classes to make it look better. Now the row reverse direction aligns the items horizontally in the reverse order. The next direction value is the column, which aligns the items vertically. Here we need to increase the height of wrapper. Let me change it to 30 rem. Now if I change the direction to column reverse, the items are getting displayed in a reverse order of columns. Let me set it to row for now. Next we have the flex wrap property, which defines whether the flex items should wrap or not. That is, it forces the flex items to stay in a single line or allows them to wrap in multiple lines. By default, it will not allow to wrap and keep the flex items in a single row. Let me resize the browser window and you can see all the 4 items are still in a single row. So giving flex wrap property with no wrap value will give the same result. Let me resize the window again to check. It is useful in the situations where you want your content or elements to be displayed in a single line and not distributed in multiple lines. Now let's set the value to wrap and resize the screen. You can see now the items are allowed to be wrapped inside their container. Next value is the wrap reverse. So let me apply that. The wrap reverse option is going to reverse the flow of flex items when they wrap on a new line, as you can see. The last property to be used on the flex container is the flex flow property. Now the flex flow property is more like a shorthand for flex direction and flex wrap properties. Let me apply flex flow and give the values row and wrap reverse. This shorthand is the same as we have defined flex direction and flex wrap properties in different lines. Let me comment those lines. You can give the values in any order, but normally this is the order which is followed, that you first give the flex direction followed by the flex wrap value. So these were the properties that can be applied to a flex container. Now let's talk about relative questions. So first is, how can you make any HTML element into a flex box? By setting the display property to flex, you can convert the HTML element to flex box. The second question is, how to align the elements to the right on the main axis using flex box. So by setting the justify content property to flex end, you can align all the flex items to the right side on the main axis, that is the end of the flex container element. What will be the default wrap value for the items when a flex box is created? It is the no wrap, which is the default wrap value, and it is set for all flex items whenever a flex box is created. Explain the difference between flex start and baseline. So when you align the items to flex start, it will align the items to the starting point or edge of the flex container along the cross axis. But when you give the value baseline, it will align the flex items along their contents baseline. Explain the difference between align items and justify content. The align items is going to align the flex items on the cross axis of the container, whereas the justify content is going to align the flex items on the main axis of the container. So this is the main difference between these two properties. Previous lecture we saw different flex properties which you can apply to the flex container. Now we will move forward and look at the properties which are applied to the flex items particularly. I am continuing with the example we saw in the previous lecture. Let me just remove the flex flow property and set the align items property with flex start. The first property we will start with is the align self property. This property accepts the same 5 values as the align items, that is the flex end, flex start, center, baseline, and stretch. Align self property helps in aligning a single element, and it also overrides the value of align items assigned to all the flex items. So right now inside the wrapper, we have the align items property assigned to all the flex items. I am applying align self property to item B. I'll pass the value flex end. And you can see it places the item B to the end of the container, overriding the align items value given to all the flex items. Similarly, if I want to center align the item, let's say item A, you can do that by giving center to the align self, and that will center the item on the vertical axis. If I want an item to stretch to fill its container's size, I will apply the value stretch to the align self, and you can see it stretches the item to its container's length. The remaining values you can have a go at it, try for yourself and see how it works out. The next property for flex items is flex basis. So let me first of all remove all the align self properties and let me give flex basis property to item A. This property takes a length value, so I will give 200 pixels. And you can see the width of the item is increased. So a question may arise, why not just give the width property? This is where the definition comes in, that the flex basis property is used for defining the size of the flex item along the main axis, that is horizontal axis, which is by default. But when the flex direction of the container is changed from row to column, the size will be applied along the vertical axis, which we can say as height of the item. So inside the wrapper, if I add the flex direction to column, you can see the flex basis is now applied as the height. There are two keyword values, auto and content, which can be applied to the flex basis. The auto defines the size depending on the main size of the element. It will still be related to the direction of the flex container. That is, for horizontal flex, the auto will consider the width of the item, and for the vertical flex, auto will consider the height of the item. Similarly, for the content, it resolves the size based on the element's content. For all the values other than auto and content, flex basis is taken the same way as any other normal width or height in horizontal or vertical flow of the axis. Let me remove the flex direction from wrapper and flex basis from item A class to reset the look. Next is the flex grow property. This property grows the size of the flex item on the basis of the width given to the flex container. So first I will comment on the justify content inside the wrapper. Next, I am going to use the attribute selector to target all the items. I will give class and caret sign, which will target all the item names starting with the word item. Inside, I will give the flex grow to 1. Here 1 represents a number and not a length value like pixels, percentage, m, etc. Flex grow property is specified as a single number. Default is 0 and negative values are invalid. So when you want the flex items to fill up the remaining space, that is the size of the flex container minus the size of all flex items together, flex grow property comes in handy. Similarly to flex grow, there is the flex shrink property, which is exactly the opposite of flex grow. It shrinks the flex item based on the width of the other flex items. So if the size of the flex items is larger than its flex container, items will shrink when applying this flex shrink on them. So first I will give flex basis instead of flex grow. I'll give 200 pixels. Now I will apply flex shrink on item A. Let's give value 2. And you can see it shrinks when I resize the output window. Similarly, if I give flex shrink to item C, let me give 3 here, and it shrinks upon resize. The value of flex shrink specifies the shrinking level compared to the other items. Remember not to use the flex wrap property with flex shrink, otherwise you won't be seeing any shrink effect, as the items will get wrapped whenever the size of the flex item gets bigger than its container. So, make sure there is no flex wrap property before using flex shrink. Next property is a shorthand for the flex basis, flex grow and flex shrink, which is the flex property. Let me remove the flex shrink property from the items, and instead of flex basis, I'll give flex property. The first value is for flex grow, second value for flex shrink, and the third value is for flex basis. This is how the order looks. You have to strictly follow this order for flex property. Lastly, the order property. This property is used for changing the order of all the flexible items. So if I want to change the default order of these items, I will do that by applying the order property. For item A, B, C, and D, I'll set the order as 2, 3, 1, and 4. And you can see the default order of flex items is changed. So these were the properties which can be applied to the flexible box items. Now let's work on an assignment. So the assignment is create a card view layout with Flexbox. Alright, I hope you have tried it. Now let's also do it together otherwise. I'll start by defining a section inside the body, giving the class name as wrapper. We will be applying the display flex property to this section as it is a container element. Now inside the section, I'll define an article tag with class name as card. Next, we need an image, so I will give the image tag giving the source alternate name and width 200 pixels. After the image, I am giving a div with class name as details, in which there will be a heading and some description inside the paragraph tag. And finally, a button which says read more. So we are ready with our first cards layout. Let me copy this and paste it 3 more times. Now let's style the card. So first, the wrapper, I will display it as flex. We'll set the flex wrap property to wrap and align the items from start. Next, styling the card, I will give border, margin, and flex property, setting the flex grow as 1, shrink as 0, and flex basis to 200 pixels. Also, let me set the contents to center aligned by giving text align property. I want to set the padding of the card and its details. And finally, for the button, I'll give a background, a border, font size, color, padding 5 pixels, width 100%, and border radius to 5 pixels. And so we have created a card view layout with Flexbox. You can resize the browser window and see how all articles adjust with the width. Though the browser takes care of calculations automatically, it is still very important to understand how this property calculates the spacing of the elements. Knowing this process helps you to understand it better. So let's look at the math behind the flex grow property. Let's work on the previous lecture's code. The only change I am applying is I'll remove the padding, margin, and order properties from every item. Next, instead of this flex property, let me give width of 150 pixels and padding of 2 rem and 0 to the items. And I will give the width of 700 pixels to the wrapper class. So we have added width to the parent element, that is the wrapper, and to the child elements, that is items. I have removed all the paddings and margins to understand how the flex grow calculates the overall width of an item, including remaining space as well. I'll now give some random flex grow values to each item. Item A will have the flex grow value set as 1, item B as 3, item C as 2, and item D as 4. Now let me open the DevTools and inspect the item. Let's inspect the item B. And you can see its new width is 180 pixels despite having width set as 150 pixels. This is how the browser does the calculations for the new width. First, the single flex grow value is divided by the total number of flex grow value. In our case, item B has a flex grow value of 3, so 3 will be divided by the total number of flex grow values, that is 10. Then that value is multiplied by the total number of available space. To calculate the available space, the width of the child elements is subtracted from the total of the parent element width. We have width set as 150 pixels for every child element, so the total would be 150 into 4, as we have 4 child elements. So by subtracting total child elements width from the parent element's width, we get the remaining, that is the available space value. After the available space is multiplied, the value which is obtained is further added with the width of that child element. By this, we end up having the new width value of that element, that is 180 pixels in our case. If I inspect item C, it has the width of 170 pixels. So if you calculate the figures using the shown formula, you get the newer width of the element. So this is how the flex grow is calculated. Media queries are very essential and important when it comes to designing a responsive web layout for various screen sizes like a mobile or tablet screen, laptop or PC, projector or a printer, etc. As it creates a view of a web page layout depending on the size of the viewport, which differs from system to system based on media types. So for viewing the web page across different devices, there won't be a need of writing new code lines which is suitable for a particular screen. You can just define the screen size or device type you wish to target inside the media query. This is what creating a responsive design means, and media query makes it possible. So for defining a media query, you'll have to give the @media rule in which you can add the CSS code for a certain condition. So let's take a look at the media query syntax. To specify any media query, we first declare the @media rule, then we give the media type, that is screen, all, print, and speech. These are the 4 types of media which are most commonly used. Then to specify the amount of screen to cover, which is also known as breakpoint, we give the minimum width, maximum width, prefixed with AND, which is a logical operator. 3 types of logical operators can be used with media queries, and they are AND, NOT, and ONLY. We can also specify orientation of the device, that is landscape, portrait, etc. Finally, inside the curly brackets, we define the CSS styles. All of these are considered as conditions, and when these conditions are met, the CSS code written in the media query is applied on the element. So let's create a simple example of media query. I will define an h1, 2 paragraphs, and a button inside the body. Now for the styling, let me apply simple styles to h1 and button. For h1, I will give color, font size of 3 rem. Button, I'll give background, setting the border to 0, color, padding 8 pixels, width 100 pixels, and the border radius of 15 pixels. Now let's apply media query. I will say at media space screen, as we want to target the media type screen, giving and inside the brackets, I will give a max width of 450 pixels. What this means is whenever the screen size gets to 450 pixels or below 450 pixels, it's going to apply the styles which I will define here inside the media query. So let me copy the above H1 style and paste it here. I will change the color and font size. Let me align the body as well. I will give body here and will center align it. Similarly, I'll copy the button styling and will modify few styles. Also, I will style the paragraphs. I will apply font size 0.8 rem and font family. Alright, now observe this. When I resize the output screen, as soon as the screen reaches the size of 450 pixels, you can see the media query is triggered and the styles are getting applied. So this is why the media query plays an important role while designing responsive web layouts. Let's apply another media query. This time I will keep the max width to 300 pixels. I will copy the above rules and paste it inside. We'll apply few modifications to them, and now when I further resize the output screen, you can see this second media query is triggered as the screen size sets to 300 pixels. So this is how the media queries are used. In upcoming lectures, we will see various layout examples as we dive deeper into this topic. Let's talk about relative questions. So what is the media query? Media query is a CSS technique which is introduced in CSS 3. It uses the media rule that includes block of CSS properties. It is the key part of designing the responsive web layouts depending on the viewports of the smaller devices. The second question is, how can you define the media query? So as we saw in the syntax explanation, that we first give the @media rule, then we specify the media type, that is screen or print, etc. And then we specify the characteristics and parameters of the device, such as screen resolution or max min width and height, etc. Now let's see a practical implementation of media query for mobile devices. I am going to define a breakpoint at 450 pixels, meaning when the screen is 450 pixels wide or lesser than that, these CSS rules will apply. I will also implement a practical point, that is when there is a mobile device, there are different resources used. Consider this example where a site contains heavy contents like HD images or videos, etc. And when they are to be viewed on a small screen device, that device will have to allocate a few extra resources to have the contents rendered and viewed. So in some cases, those contents are skipped when they are rendered on small screen devices to save resources in order for the device to work smoothly. This is where the media query comes into picture. And this brings me to a question that how are media queries helpful when it comes to saving resources? So let's try to implement this example where we will have heavy resources that needs to be skipped when loaded on small screen devices. Let me continue with the previous example. I will add 2 images right before each paragraph. I'll set the width and height to 100% for both the images. Next, inside the media query having the max width of 450 pixels, I'll set the display property to none for the image. So this will hide both the images when the screen size shifts to 450 pixels or lower. I do not want to repeat the same line of code for the media query having the max width of 300 pixels, As the screen size reaches 450 pixels, it will implement this line of code for all the screen sizes which are lower than 450 pixels. Let me bring the output window to its full length. Now when I resize the window, you can see the images are getting hidden as the screen size reaches 450 pixels and lower. At the moment, because I am resizing, you see that images are getting hidden. Ideally, when it is opened on the smaller devices, the images will not be loaded in the memory. That's the advantage. That's where the performance will be improved with the smaller devices. So with this, the resources which are occupied by the device for viewing the images remains free. Now this is an important factor when the page is being viewed on a small screen device. The media all query is the query type which is used when you want to target all the devices. It is suitable for all device types. So let's create an example to understand it more clearly. I will start by defining a heading. Next, I will create a menu. So I will create a division, and inside I will define an ordered list and also list items with hyperlinks, that is anchor tags, having home, about us, contact and support as the text, and then a paragraph. Let's style them now. I'm giving color, font size of 3 rem and text align as center for heading. For UL, I'll give the list style to none, and this will remove the bullets. Giving display property as flex and will justify the content to center. So this will center align the links. Also, I'll keep padding to 0 to remove any unwanted padding. Next, for styling the links, I'll give margin 1 rem, text decoration to none for removing the underlines, and then the color. For styling the paragraph, I will give padding 1.5 rem, top bottom margin 30 pixels and right left margin 50 pixels. Font size 1.2 rem, background and color. Alright, so we are done with the basic styling. Now let's make it responsive by adding a media query. So I will add the @media rule, and I want to target all devices. I will give the media type as all and will give the max width to 400 pixels. So when the screen size gets to 400 pixels or lower, the styles which I will add in this media query are going to get applied on the elements. By default, the media type is all. So if I don't specify any media type, the CSS parser will take the media type as all, but it's better to specify the media type when working with them. Alright, so let's style the H1. I will copy the above H1 styling and paste it here. I will change the font size to 2 rem and will remove the alignment. Next, I'll style the paragraph, giving font family, text align, center, font size 1 rem, font weight, bold and background. I'll change the display property of UL to inline block, and you can see it aligns the links vertically. And to add some space between them, let me add margin to li. I will give the bottom margin to 15 pixels, center aligning the division as well to make all the links appear in the center. And finally, I will style the links by applying just the color. Now when I resize the screen, you can see how the menu gets adjusted as per the mobile view. One more important point to remember is that the media query works just like any other selectors. For example, if I bring the H1 selector below the media query and resize the screen, you can see no matter what screen size it is, the heading styles stay the same because it is reading from top to bottom, and it always takes the bottom selector if the selector has the same specificity. Okay, so let me undo this and check the output again, and it's working fine. Again, to summarize, all will target all the media types, and it is a default media type taken by the CSS parser when no media type is specified. So even when I remove this all and, you can see it still works fine. But it is still recommended to give the media type explicitly, as there are still some bugs and issues faced by the developers when working with all. But still, if you want to target all the devices, you can go for it. Media type screen is used specifically for the computer screens, smartphones or tablets, basically screens. By giving the @media screen, you can target various devices' screen. So let's create an example. I will define a section with class name as main. Inside I'm going to define 4 divisions, each having a heading as column 1, 2, 3 and 4. Let's style these columns. I want to display them as a grid when the page is being viewed in desktop. So I will give the display grid to the main container, and I will define the 2-column layout of one fraction. Next, I will style the column by giving background color, border radius 15 pixels, margin 12 pixels, padding 14 pixels. Now I want to display this grid layout in a columnar layout when it is being watched on mobile or tablet devices. So for that, I will give a media query with screen as media type and orientation as portrait. I will display the container as flex and change the direction to column. So when the width of the screen is smaller than the height of the screen, it's going to convert the grid into a columnar flex layout. Let me style the columns as well. I'll copy the styles from above and paste it here, applying few modifications. And now when I resize the screen, you can see it converts the grid layout to columnar layout. This similar thing can be achieved by a different approach, and that is by specifying screen width sizes for different devices. The print media type is generally used when you want to print the web page on a paper. It is intended for paged material and documents which are to be viewed on a screen in print view mode. So let's move to the example. I'm going to define a section which will have a heading and 2 paragraphs. Let me now apply some basic styling to them. For H1, I will give color, font size 45 pixels and the text alignment to center. For paragraph, I give only the font size of 1.2 rem. Now I'll apply the print media query. If you want, you can specify the max min width, but for this example, I will just say @media print. I will copy the styles of H1 and paste it here. I will change the color, font size, and I'll give in point unit as they are widely used for printing documents. I will align it to center and will give the font family. Similarly for paragraph, let me give the font size in points. I'll say 16 point and font family. Alright, if I resize the output page, nothing is happening because to see the result, I need to print this page. So let me open the page in browser. I'll press Ctrl P for printing the page and you can see the result. The color and the font size is changed as the document goes in print mode. The purpose of using the print in media query is quite simple. If the web page contains a lot of colored elements or various functionalities which are to be printed on the page, you can just apply the print media query with common colors shared by all the elements. This way you will be saving many resources and the need of printing the web page layout on a page gets fulfilled as well. For example, instead of giving different colors, if I apply similar colors to these elements And now when I print the page, you can see the elements share a similar color. So there won't be any clutter about the colors, and you can present the web document on a page with ease. Most of the time you will see that when you take a print, you will have the black and white combination. So that can also be configured inside this media print. So this is how the @media print works. Now let's talk about questions. So explain the difference between media screen and media print. So media screen targets the screens of particular devices like smartphones, tablets, PC, laptops, or any for that matter. Whereas the @media print is used for printing media, that is printing the web page layout on a paper. This is the major difference between these two media types. Breakpoints are generally referred to as the pixel values that a developer sets inside a media query. Upon changing those dimensions, some transformation occurs to a website which provides optimal user experience known as responsive designs. In this lecture, I'm going to code a simple yet responsive form by setting breakpoints for different devices. So let's begin. I will start by giving a heading saying sign up form. Next, I will give a division with class name as my form. I'll give the form tag now, and inside I will define two divisions having class names as row and column. Inside the column division, I will give a label as first name and its input. I will copy this column division and paste it 3 more times, changing the label and input as last name, email, and password. After the row division ends, I will define a button inside another division. Let me define the class name of the division as submit button and giving the button name as sign up. So our form is ready. Now let's style it and make it responsive. I'm going to style the heading giving text align to center, color and font size 35 pixels. Next, styling the my form giving border, displaying form as flex, justify content to center, setting flex wrap as wrap and border radius to 5 pixels. Next, for the row division, I will display it as grid and will define 4 grid columns. I'll just keep them as auto. Next, for the column division, I will give top bottom padding 0 and right and left padding to 10 pixels and top and bottom margin to 10 pixels. Also right and left margin to 0. Now let me style the input. I'm giving border none, padding 10 and 25 pixels, background color, margin auto, width 75%, color white and font size to 1.25 rem. Similarly, the label, I'll display them as block, giving color and bottom margin to 5 pixels. Next, let me style the division which is holding the button. I'll just center align the button and will give the margin 20 pixels. Next, I'll style the button. I'll give padding 5 pixels and 20 pixels, background, border to none, border radius 5 pixels. Let me also specify the text transform to uppercase and font weight to 700 with the font size 1.25 rem. Now we will add breakpoints through media query. So the first breakpoint will be at 900 pixels. I'll give row and I'll bring down the columns by 2, reducing the font size of the body, inputs and button to 1 rem. So when I stretch out the output window, you can see the form in 4 columns, and now when I resize the window, it is getting divided into 2 column layout. I will add another breakpoint of 600 pixels. Let me copy the row style from above breakpoint and changing the template columns to just auto, that is single column layout. And I will give padding 0 to column and margin, let's say 10 pixels and 0. Now we are ready with our responsive form layout. Let's check it once again. So with this kind of approach, that is by setting breakpoints, you can easily create a responsive layout for any website. Let me also share the list of widely used breakpoints for targeting various devices' screens.